Greetings all. I'm Rohit. We are proceeding with the problem statement ID AB07 Open Innovation. Our team members are Niranjan S, Rohit SK, Aravindan A, and Andrew Jason R. The problem statement is AI is being revolutionized in each and everyone's life in this whole world. And we wanted to focus on the small scale businesses who don't have enough of resources to hire a data analyst or a machine learning engineer to implement machine learning into their own business to gain more profits. For that particular thing, we made a solution out of it. That is the automated ML. We made the complete process of machine learning automated through our AutoML project. Here we do have less human interaction and the user just needs to be giving the input, that is the data set, and the dependent variable that is need to be predicted. We included some libraries such as scikit-learn, logistic regression, and all other machine learning algorithms that's being implemented already to make it much more optimized. The architecture that we have here is we are going to get the dataset from the user, and we are going to optimize the matrices that is being included in the machine learning and time constraints to make it much more optimized by reducing the time complexity as well. Here the model training and everything, all the process from pre-processing to the model selection is being done. Comparison with the other models of the automated machine learning that we have, AutoScaLearn, Vertex AI, and Azure ML, they don't have proper pre-processing technique and feature engineering technique that optimizes the whole machine learning part. We have implemented all those things into our project, the AutoMagic ML or the automated ML. So we all did this with the help of genetic algorithm, and that making the feature engineering process much more easier and making the whole process of machine learning much more simpler. Handling varieties of dataset was the biggest challenge for us because every dataset have different insights out of it. The second problem that we faced is understanding the dataset. So without human interaction, it's very tough for us to understand the dataset, so that we need to be making the model much more generic and applicable for all the use cases. Pre-processing technique is really important to make the model much more accurate without any data loss and bias. Feature engineering part, we just implemented that particular part of this process of making this project to genetic algorithm, and we optimized this genetic algorithm by including dynamic algorithm into it, and thus it reduced the time constraints that we have. That was one of the biggest challenge when we approached through statistical model, which actually didn't have a bigger difference from the existing model that we have made and already being existing. So we included the dynamic programming and the genetic algorithm into a model so that the accuracy got increased and also reduced the time complexity of the model and also reduce the model complexity as well. Let's get into the implementation part. So here we have the Streamlit, and let us choose our dataset. Once we choose the dataset, we can view the data by clicking the view data. So here we can see that we have the column named as target, which is our dependent variable. So right now we can move towards the model training and choose our target variable, that is target. And once the training button is being clicked, the training process start. Here we will choose the best ML model that we have to be implemented, and also the genetic part of the algorithm is also being implemented as well. Once it's done, through the genetic algorithm, the best features are being selected. Initially we have all the features available, and the second we have the features that are very applicable to our model to make it much more complex, much more simpler as well. And we can see that we could have a better accuracy in our model of 94.15 than the 92. And here we will include all the inputs that we need to be needs to be done so that we can predict the output. Once it's done, we could press on the button named as predict. So then we'll be getting the result that we needed, that is 1. So yes, and right now we can go to the data visualization, and we can perform, or we can get to know what all the visualizations things that we could get out of the data set that we have. All the insights could be derived using this particular website that we have. And also we could save our model when we move to the best model column, and we could save the model as well, and it can be used for the further purposes as well. Sum up of visualization results of the model that we made. So we have a better accuracy of most of the time. So here we could see for the hot disease we have high accuracy than the complete data set that we have. And we used to have a bit of a compromise of 0.2 or 0.02% in our accuracy, but we have a faster training time results as well to various data sets being included. This is our automated ML project. Thank you.